Prisms are a certain kind of shape, but what makes them stand out? A prism is two polygons, or multiple-sided closed shapes, joined together to form an enclosed three-dimensional shape. For example, a box is a prism because it consists of two squares or rectangles joined together to make the enclosed three-dimensional figure seen here. Two-dimensional shapes make the flat top and bottom sides, or faces, of a prism. So any box, stacks of post-it notes, and even legal pads are all prisms because they're three-dimensional objects with congruent polygons as faces. There are 5 rules for identifying a prism. Rule 1 is that the faces of a prism must be polygons, so even though it may seem that cylinders would be prisms, they don't fit the definition. This is because their faces are circles or ovals which don't have sides and are therefore not polygons. So a can isn't a prism. No sides, no polygons, no prism. A prism can have triangles as faces. Rule 2 states that the sides of a prism must be parallelograms. Parallelograms are quadrilaterals whose opposite sides are parallel. Consider a box and a triangular prism. All of their sides are parallelograms. The third rule says a prism's faces must be parallel. If one face lies at an angle to the other, they will at some point intersect, and the figure is not a prism. Also, if the faces aren't parallel, the sides won't be parallelograms. In this figure, for example, the rear face lies at an angle compared to the front face. As a result, 2 of the sides are not parallelograms. Non-parallel faces create sides that are not parallelograms. Rule 4 states that the bases must be congruent. Congruent means the exact same shape and size. A figure that has differently shaped faces creates sides that are not parallelograms. Since the faces are not congruent, this figure isn't a prism. Lastly, Rule 5 says if a cross-section is taken of a prism parallel to its faces, the cross-section would be congruent with the prism's faces. This happens because the faces are congruent and parallel.